Students, when I'm speaking about with respect to circular motion, students, motion of a body along the circumference of a circle, okay, or motion of a body along an arc of constant radius, okay, along an arc of constant radius is called a circular motion, students. Now, to start up a circular motion, I'm giving you one question only, students. Let's see how many of you can get the answer for this. Students, have you come across a concept of looping a loop, or have you come across examples for objects undergoing looping a loop? No, students? For example, if you happen to consider air shows, students, शायद तुम लोग ने air shows देखा होगा तो वहाँ पे aircraft looping a loop होता है into the air itself only, and that's vertical circular motion, students. वैसे ही शायद, I don't know about it, when you were small, you must have played around with Hot Wheels. है ना students? खेलो students with Hot Wheels. Students, have you all played with Hot Wheels?
Yes, sir.
Okay. Now my question to you students, students. यहाँ पे एक car है students. The car is over here, students, and this car is set to, it's a toy car, okay, Hot Wheel car, okay. I want this particular toy car, it's moving down the inclined plane, students. Okay. The height through which it is made to be released is 5/2 times the radius of the circular path. यानी ये point A है, ये point B है, ये point C है, और ये point D है, and point O is the center of the circular path. Students, listen carefully. मैंने यहाँ से कार को release किया, students. My question to you is, when the car reaches at point D, students, मुझे बताओ, what's going to happen to the car? Will the car will drop perpendicularly downwards? Okay. Will the car will have a parabolic path, or the car will go tangentially outwards? Which path the car is going to have? Will it fall vertically downwards? Will it go parabolic path, or will it go tangentially outwards? Anybody? Anirudh says tangentially outwards. What about the rest of them, students? Students, ये एक vertical circular motion है. यहाँ से car release हुए जैसे आएगा, what happens? As it reaches at this point, what happens? Of course, it's going to go tangentially. No, my dear. Yash, how it's going to be parabolic? Think, Yash, think in that case. The answer सुना, students. Listening carefully. Suppose अगर तुम्हारे हाथ में मैंने एक rope दिया है या thread दिया, and if I tie a stone to it, and I'm revolving in a vertical plane. Students, look over here. Look at my hand. Look at my hand. Look at my hand. As I revolve and think as if the stone has reached at the topmost point. उसी instant पे suppose अगर मैंने thread को काट दिया, how exactly the stone is going to go? Tangentially. यानी ये path third वाला, second वाला भी नहीं होगा, first वाला भी नहीं होगा. Can I say it's going to be the third path in this case? क्या ये clear हुआ सबको students? Yash, is it clear?
Yes, sir.
Sanjana, is it clear? Sanjana, are you there? Knock, knock. She's not there. Janani, is it clear to you?
Yes, sir.
Okay. Now my question to you students, can you find out the velocity of the car at point D? Chalo. Anybody can give me the answer for this?
Sir,
Yes.
so we need to continue this circular motion in this fluid chapter only, fluid mechanics.
No, but yeah, it's a new topic to work out with.
Okay, sir.
Okay. Try to solve it, students, fast. Pathway, did you attend work energy power lectures, Pathway?
So actually today is only the work energy power lecture for our batch. So that's why I was asking.
शायद
Sorry,
कल ही
sir.
मुझे
We have a center of mass today in our timetable.
Jananda sir told me to take this part of it. And work power energy, yesterday only I finished with it. It was with
Sir,
red.
I didn't got the link or the message of that lecture.
It wasn't, it was for red and some other batch. Purple. पूरा chapter हो गया वहाँ पे पहले.
Sir, we didn't
मैं
get
समझा.
the link for work energy power.
Yeah, sir. That what?
Oh God. Doesn't matter.
Sir,
Doesn't
could
matter.
you just provide us with the recording? We can see that.
Okay, then I'll provide it to you. Okay.
Okay, sir.
I'll
Thank you.
Fine. You can just send me a message in that case. Okay. Saying, sir, I'm Parthu in that case, and whoever is in need of it, you can hand it over to that person also. Okay. I'll send it to you.
Yes, sir.
Okay, students, give me the answer for this. Yes, anybody? Come on, Akshata, Arshit, Chinani, Kirti, Meera, Parthvi, Om, Pranshu, Sanjana, Shreyas, Shivam, Pages, Tushar, Udit, Yana. Yana, how are you, Yana?
Yes.
Can you answer for this question, Yana?
I don't know.
Vidhi, what about you? Yana, solve it for me.
What?
Yana, are you there? Solve it for me. Shall I give you a hint, Yana?
Yes.
Okay. The car is released from point A and it is going tangentially at point D. Okay, Yana, just simply used law of conservation of energy. Now, can you get an answer? What is the total energy when the car is at point A, Yana? Will it have kinetic energy or will it have potential energy or will it have both?
Potential energy.
Very good. Potential energy at point A. Now, when it reaches at point D, will it have kinetic energy or potential energy or both?
The kinetic energy.
Why? It doesn't have position, doesn't have a height from the ground, twice radius.
Before that,
Yes.
Agreed?
Yes.
So, will it have kinetic energy? Yes. Will it have potential energy? Why not? Got it, Yana?
Yes.
Okay, can you tell me what's the potential energy at point A? What's the formula for potential energy?
MGH.
Very good. So it's mg, and what is h? 5/2r.
R. Yes.
Please write to the students. What is kinetic energy at point D? Can I say it's half mv square?
Half MG square. Yes.
And what's
Yes,
the
sir.
potential energy of the car at point D?
That's
What is
again
the potential?
MGH.
Absolutely correct. mgh. What is h? Twice radius. What did I tell you to find out this? Velocity. Agreed?
Yes.
Students, the rest of the students, are you getting it? Parthui, are you getting it? Sanjana,
Yes, sir.
Kirti. Kirti, are you there? Now see students, if I try to shift this, what will be? It's 5/2 mgr students minus 2 mgr is equal to half mv square. Agreed? What is 5/2 minus 2? So that will be equal to 4/2 students. So what exactly my answer will be? Sorry, 5/4, that is mgr by 2 is equal to half mv square students. M will get cancelled, we consider. Is that clear? 2 also will get cancelled. Students, what's the velocity? Under root gr. Is it clear?
Yes, sir.
Is it
Yes.
clear? Now I want to ask to those students who have done, circular motion in the schools. Okay. Kirti, vertical circular motion, have you done it in schools? Reply, Kirti.
no, sir.
So somebody has done it, isn't it? Let me ask Anirudh. Are you there,
No.
Anirudh?
Yes, sir. So we don't attend school lectures, right? Because our classes clash times.
Okay. Okay, fine. So mind you, students, when you're solving this exactly into circular motion, you can go in a different manner also by using the concept of circular motion. लेकिन students ध्यान से सुनना, ये question के लिए कहाँ पे भी मैंने circular motion का concept लिया students? Or did I use concept of energy?
Energy.
Energy. Agreed. And when I use concept of energy, simply law of conservation of energy, we can get the velocity at that point. And students, do keep in mind, listen carefully, which I'm going to put forward this relation also. Students, for vertical circular motion, everybody listen carefully. For vertical circular motion, for a body, not to lose any contact at the topmost position, the minimum speed of the body should be under root gr. The minimum speed of the body at the topmost position for vertical circular motion should be under root gr for not to lose any contact. Yani students, a simple example I'm giving it to you. Students, you can try this at your home also. Okay, and I mean it, students, after the lectures, you can try it out. You take a small bucket, if you have a small bucket of it, okay, small bucket of, we consider with a handle, okay, you fill this with water, students, fill up to its brim. Then hold it with your hand, students, and you start moving your hand. You just swing your hand in a vertical circle. Students, when the bucket is at the topmost position, listen carefully, this is the bucket, ye handle hai, agreed? And when the bucket is at the topmost position, students, the bucket is inverted. The bucket is inverted. This is the center. The bucket is inverted. And it's at the topmost position. But still, not even a single drop of water will spill. Not even a single drop of water will fall downwards. In order for the water for not to lose any contact, exactly the way for the car to not to lose contact. Students, the minimum speed at the topmost position should be under root gr. And when do you get this particular speed? Only when the speed at the lowest position is under root 5 gr, which I'm going to put forward. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Is it
Yes,
clear?
sir.
Okay. Now, students, let us go for circular motion. Students, so when you start with circular motion, I simply gave you a problem itself only, and that was simply based on the law of conservation of energy. So, circular motion का मतलब क्या है? Motion of a body along the circumference of a circle or along an arc of constant radius, we call a circular motion. Agreed? Now, when I speak about for circular motion, can I erase this, students? क्या मैं इसको erase कर सकता हूँ?
Yes, sir.
Okay, students. Now, when you speak about circular motion, students, do keep in mind. In circular motion, students, if the magnitude of velocity, students, remains constant, then what kind of motion is this? And if the magnitude of velocity does not remain constant, then what kind of motion is this? For circular motion का मतलब क्या students? Motion of a body along the circumference of a circle, students, with a constant radius, constant radius, or along an arc of constant radius. Such a motion is called a circular motion. Students, it's a circular motion we consider. Okay, it's along an arc of constant radius we consider. O is the center of the circle. But if the speed remains constant, students, then what kind of motion is this called? Uniform circular motion. If speed does not remains constant, this is called as non-uniform circular motion. Students, the word UCM stands for uniform circular motion. This is non-UCM. यानी यहाँ पे speed constant होगा. Students, यहाँ पे speed constant नहीं. Motion is accelerated. Friends, my question to all of you all, is this a correct statement? Motion is accelerated for UCM as well as for non-UCM. Is it a correct statement? If it is correct, why correct? If it is wrong, why wrong? Students, is the question clear?
Sir, may I answer?
Okay, yes, Parthy, answer.
So according to me, this sentence is correct because the velocity is changing
Means what is
at
changing?
every point.
So what is changing in this case? What is changing in this case for UCM?
The direction.
Absolutely correct. Over here, what is changing?
The direction and
As
the
well as
magnitude.
Both. But what is common in both the cases?
Moving in
Direction.
circular path.
No, direction of motion goes on changing. दोनों केस में, है ना?
Yes, sir.
Yani, absolutely correct. Students, Parthy, she gave a correct answer. Motion is accelerated. Motion is accelerated. Ka matlab, what exactly consider is? Students, if in case if I happen to go for circular path, please everybody, it's a very, very important statement to be taken care of. If somebody asks you, is uniform circular motion accelerated motion? Your answer should be yes. Is non-UCM an accelerated motion? Your answer should be yes. What is common in both the cases? सर अगर पार्टिकल, ध्यान से सुनना स्टूडेंट्स, अगर पार्टिकल यहाँ पे है तो उसका टेंजेंशियल वेलोसिटी ये होगा. सर डायरेक्शन ऑफ वेलोसिटी यहाँ पे होगा स्टूडेंट्स. अगर पार्टिकल यहाँ पे है तो उसका डायरेक्शन ऑफ वेलोसिटी ये होगा. अगर पार्टिकल यहाँ पे है तो उसका डायरेक्शन ऑफ वेलोसिटी ये होगा. अगर पार्टिकल यहाँ पे है तो उसका डायरेक्शन ऑफ वेलोसिटी यहाँ पे होगा. अगर पार्टिकल यहाँ पे तो ये इसका टेंजेंट बन गया, ये हुआ डायरेक्शन ऑफ वेलोसिटी, ये है सेंटर. What about the radius of the circular path, students? This is called as a position vector, also called as a radius vector. What exactly position vector or radius vector shows? It always shows the instantaneous position of the particle. Particle उस टाइम पे कहाँ पे है? Particle उस टाइम पे कहाँ पे है? Who actually shows that? The position vector. or the radius vector. Look at the radius vector over here. So this becomes my radius vector. Look at the radius vector. This is the radius vector. Look at the direction of radius vector, students. Is the direction of radius vector goes on changing at each instant? Yes, sir. Magnitude, students, magnitude of radius vector always remains constant. यानी यहाँ पे magnitude of radius vector sir remains constant. यहाँ पे भी magnitude of radius vector sir वो भी remains constant. लेकिन क्या यहाँ पे magnitude of velocity remains constant? Yes, but direction goes on changing at each instant. Students, at each instant, how is velocity and position vector? At each instant, how is velocity and position vector? So velocity and position vector are mutually perpendicular, mutually perpendicular, mutually perpendicular all the time. Oh, yani for uniform circular motion, speed remains constant, magnitude of position vector remains constant, but your tangential velocity and position vector are mutually perpendicular to each other. Therefore, we say direction of velocity changes at each instant, and therefore we say motion is accelerated. यहाँ पे भी क्या है सर? यहाँ पे भी velocity and position vector are mutually perpendicular. Therefore, motion is accelerated. Even does the magnitude of velocity remains constant? No. Does the magnitude of position vector remains constant? Yes. But यहाँ पे V और R दोनों का position goes on changing at each instant. यहाँ पे magnitude of velocity also and direction also goes on changing. But every time they are mutually perpendicular to each other. Students, such a motion is called circular motion. यानी स्टूडेंट्स अगर कोई भी टीचर तुम्हें एक चीज सर्कुलर मोशन के बारे में पूछे ना, स्टूडेंट्स व्हाट एग्जैक्टली सर्कुलर मोशन, तो तुम्हारे मुंह से क्या होना चाहिए? इट इज एन एक्सेलरेटेड मोशन. ये वन लाइन आंसर है. सर्कुलर मोशन इज अ मोशन अलोंग द सर्कमफरेंस ऑफ अ सर्कल ऑफ अ पार्टिकल हैविंग एक्सेलरेटेड मोशन. तुरंत तुम्हारे टीचर फिर दूसरा क्वेश्चन पूछेगा, हाउ कैन यू से एक्सेलरेटेड मोशन? तो तुम्हारा आंसर क्या होना चाहिए? सर एट ईच इंस्टेंट the tangential velocity and the position vector are mutually perpendicular to each other. Your teacher will ask you, how can you say that? How can you say that? Then your answer will be, since V and R are mutually perpendicularly throughout the motion, therefore students, what will be their dot product? Can you tell me what will be their dot product? V and R का dot product क्या होगा students?
0.
0. So can I say dot product will be 0 because the component will be cos 90 and cos of 90 will be 0. क्या ये clear हुआ students? Students, is
Yes,
this?
sir.
Yes, sir.
तो जब भी तुम circular motion के बारे में जानना है तो ये बहुत important है. Now students, देखो velocity remains constant. Students, यहाँ पे velocity remains constant. So what about the angular displacement? Students, theta. Students, theta traced by the particle. Students, theta traced by the particle during the circular motion. Suppose if I see the particle starts from here and here, it traces equal theta in an equal interval of time, equal theta in an equal interval of time, equal theta in an equal interval of time. So it traces equal theta in an equal interval of time. Therefore, can I say, students, what is the angular velocity of the particle? The angular velocity of a particle performing circular motion is what? Is 2 pi by t, and that all the time remains constant. The unit of this is always in radian second. Students, क्या ये clear हुआ students? Is this clear students? If a particle performs uniform circular motion, it's a circular motion, students. So can I say it's going to trace equal angle and equal interval of time? Let us say the particle, the answer is enough. Please pay attention, students. Let us say the particle starts from point P. It goes all the way along the circumference and comes back to point P. Students, जाके वापस आ गया. So can you tell me what is the total angle traced by it? 2 pi. What is the time taken for this complete motion? Periodic. What's my formula for omega? 2 pi by t. So can I say omega is actually 2 pi by t Yeah, 2 pi f. And what is the unit? Radian second inverse. But is omega constant for UCM? Yes. Students, uniform circular motion is that kind of motion in which the magnitude of velocity remains constant, the magnitude of position vector remains constant, the direction of velocity and the position vector changes at each instant. They're always mutually perpendicular to each other. The dot product is always equal to 0. But the angular velocity of the particle performing circular motion all the time remains constant. क्या ये clear हुआ students?
Yes, sir.
अगर यहाँ पे एंगुलर वेलोसिटी कांस्टेंट है तो यहाँ पे एंगुलर वेलोसिटी क्या कांस्टेंट रहेगा? और स्टूडेंट्स मुझे बताओ।
No. It
नहीं,
was
यानी इसका मतलब क्या हुआ मालूम है? ध्यान से सुनो स्टूडेंट्स, इसका मतलब क्या हुआ? इसका मतलब ये हुआ, ध्यान से सुनो स्टूडेंट्स, particles at point P. Let us say the particle covers might be θ1 in first 10 seconds. Then in next 10 seconds it might cover an angle θ2, might be greater. Who knows? Who knows in that? In next 10 seconds, the particle covers θ3. Is it covering equal angle? Is the particle covering equal angle in equal time? Not at all. Friends, such kind of motion is called non-UCM. यानी students, यहाँ पे angular velocity is not constant. Agar angular velocity is not constant, students, so how do you write down the formula for angular velocity? That angular velocity is change in angular displacement with respect to change in time, and the unit is radian second inverse. क्या ये clear हुआ students? Yes. Omega is not constant. Omega will be what? D theta by dt. Students, यहाँ पे omega देखो. What is omega? Theta by t. Students, everybody listen carefully. Omega is actually theta by t यहाँ पे. And omega constant क्यों बोला? What? Suppose if I say a particle starts from P and it comes back to point P, what is theta becoming? 2 pi radians. The complete angular trace will be 2 pi. What is the time taken for it? Periodic. Suppose if I go for 2 circles, 4 pi, what is the time? 2t. 6 pi, 3t. 8 pi we consider. It goes on increasing time, but all the time 2 pi by t remains constant. यहाँ पे constant. यानी स्टूडेंट्स यूनिफॉर्म सर्कुलर मोशन में एंगुलर वेलोसिटी कांस्टेंट होगा, यहाँ पे एंगुलर वेलोसिटी इज नॉट कांस्टेंट. हाँ लेकिन यहाँ पे मोशन एक्सेलरेटेड है. क्यों भाई? क्योंकि डायरेक्शन of velocity and position vector changes as well as magnitude of velocity also goes on changing. Have you understood the clear meaning of circular motion? Students, is this clear?
Yes, sir. Yes, sir.
Circular motion is motion of a body along the circumference of a circle or along an arc of a circle of constant radius such that the direction of linear velocity and the position vector at each instant are mutually perpendicular to each other. That means the velocity goes on changing at each instant we consider. Such a motion is called circular motion. If the speed remains constant, it's UCM. If speed does not remain constant, non-UCM. In uniform circular motion, angular velocity is also constant. Angular velocity is not constant. The unit of angular velocity is radian per second. Is this clear? Can I erase this, students? Students, can I erase this now?
Yes, sir.
Yes, sir.
Okay, students. Now, when you speak about with respect to different physical quantities associated with circular motion, listen carefully. So the first one, please pay attention. The first thing which I made you to understand is theta. Students, let us say S and let us say R. Students, theta stands for plane angle. Okay, and that is angular displacement. So I'll put down much more better as angular displacement. Okay, and this is always measured in radian. So this is called as linear displacement or length of arc. I simply consider length of arc, which is always in meter or centimeter. And this is your position or radius vector. Okay, which can be in meter or centimeter. So can you give me a relation between theta, S and R? Can you give me a relation between theta, S and R, length of arc, angular displacement, and radius, which many of you all must have done it in math?
S is r theta. S is equal to r theta.
That means if I write on S is a vector, yes, it's theta, which is also vector. R is also vector. Please try to understand the students. ये ध्यान से समझना. Students, अगर मुझे relation चाहिए तो S is equal to theta cross R. अभी ध्यान से सुनो students, please everybody say carefully. To understand this, we are going to go for vectors also. Students, यहाँ पे vectors भी पढ़ेंगे हम. Students, अभी ये सोचो कि I'm taking a rectangular plane. Students, I'm taking a horizontal plane. Let me take this as a horizontal plane, students. और ये तुम्हारा x है और तुम्हारा y. Students, it's an xy plane. This is center. And if I say that a particle is performing circular motion in an xy plane, please everybody listen carefully. The particle is performing circular motion. Think that as this is a circular motion. Students, मैंने top view दिया है. मैंने ये particle का circular motion है और वो anti-clockwise move हो रहा है. Students, it's going in anti-clockwise direction, counter-clockwise, and I'm showing you the top view. Agreed? So ये तुम्हारा x-axis है, your y-axis है, looking at in this manner. X-axis, y-axis. My thumb will show you the z-axis, students. So if in case if I happen to show the direction of the thumb, so my thumb is going to point in one direction, upward direction we consider. This is how I consider. Okay. So this is z-axis. So can you see this is k cap? This is I cap. And this is j cap. Now students, ध्यान से सुना, अगर मुझे s theta r को यहाँ पे बताना है तो कैसे बताऊंगा? तो तुरंत तुम क्या करोगे? सर क्या सर इजी है सर, ऐसा करो ना, राइट हैंड स्क्रू रूल पकड़ो वेक्टर्स में. स्टूडेंट्स, डू यू करेक्ट? I j k motion anti-clockwise. Everybody, those who have done vectors, please concentrate over here. Listen carefully. What is my subject? Students, over here, what is my subject? My subject is S. Please, students, can you tell me where exactly linear displacement of the particle performing circular motion will be? Students, this is actually a particle performing circular motion. And if I say speed remains constant, that becomes UCM. So let us say a particle is performing uniform circular motion. Students, अगर मैं बोलूँ uniform circular motion है, then its speed remains constant. I can consider. Whichever the students, where exactly the direction of linear displacement will be? Can you tell me, will it be along x-axis, or will it be along y-axis, or will it be along z-axis? Can anybody tell me that? Linear displacement of the particle. Jaldi se. What is the direction of linear displacement for a particle performing circular motion in an xy plane? Particle is moving in an xy plane. Where is the direction of linear displacement? Fast. Come on, students, what are you doing? अगर particle horizontal plane में move हो रहा है, ध्यान से सुनना. Particle, for example, you're holding a thread. There is a stone, and you're revolving it in a horizontal. Of course, Kitty, तो unmute करके बोला ना जोर से. Tangentially जाएगा ना. अगर तुमने ऐसे revolve किया और जैसे तुमने string को काट दिया. Friends, how exactly this particle is going to go? So this particle is going to go tangentially. Yani students, do you see this vector? Do you see this particular arrow? Is this arrowhead parallel to y-axis? Yes. So your particle is going to go along which axis? Y-axis. Any concept terms y-axis में जाएंगे? Sir, linear displacement will be along y-axis. ध्यान से सुनना. Tangential velocity will be along y-axis. Velocity upon time. Acceleration tangential will be along y-axis. Mass into acceleration. Force tangential along y-axis. Mass into linear velocity, linear momentum along y-axis. So all these physical quantities will act along which axis? Y-axis. क्या ये समझ में आया सबको? Students, क्या ये समझ में आया सबको? Everybody?
Yes, sir. Yes, sir.
पार्टिकल परफॉर्मिंग सिंपल स्टूडेंट्स, एकदम सिंपल कंसेप्ट है। पार्टिकल अगर सर्कुलर मोशन में है और सपोज मेरे हाथ से छूट गया, तो डिस्प्लेसमेंट, सर जिस डायरेक्शन में डिस्प्लेसमेंट होगी उसी डायरेक्शन में वेलोसिटी होगी, उसी डायरेक्शन में मोमेंटम होगी, उसी डायरेक्शन में एक्सेलरेशन होगा, उसी डायरेक्शन में फोर्स होगा, सारे एक ही डायरेक्शन में होंगे, सारे जे कैप में है। Students, which vector is acting along x-axis? Which vector is acting along x-axis? तुम बोलोगे सर it's a position of a particle. ये r bar है, ये center है. Students, look over here. Is your V, is your V, is your V, and is your R mutually perpendicular? अरे हाँ सर, V and R has a dot product, tangential. है ना? यानी तुम्हारा R कौन से axis पे हो रहा है? Sir, R is acting along I cap. Yes. What about S? Sir, S is acting along J cap. Then where should be the position of theta? Where should be the position of theta? So theta will be certainly acting along what? Positive Z for a particle performing circular motion in anti-clockwise direction. Now students, look over here. When I wrote this equation, did I write down using right-hand screw rule? Using right-hand screw rule, everybody concentrate. S bar as a subject. S bar, yani J is equal to K cross I. Students, याद है vectors? Anti-clockwise direction में students, what is K cross I? Plus J. कुछ याद आ रहा है? K cross I
Yes.
plus J. What is J cross K? What is J cross K? Plus I.
I.
Okay, what is K cross I?
J.
Plus J. If I happen to go in clockwise direction, students, what is J cross I? What is J cross I?
K.
Very good. Minus K. What is I cross K?
Minus J.
Minus J. And what is K cross J?
Minus I.
Where have you learned all these things? ये हम लोगों ने कहाँ पे पढ़ा? सर्कुलर मोशन में. Students, ये किसके लिए है? ये क्लॉकवाइज मोशन के लिए और ये एंटी क्लॉकवाइज. यानी स्टूडेंट्स, अगर लीनियर डिस्प्लेसमेंट, लीनियर वेलोसिटी एक्टिंग ऑन वाई एक्सिस, पोजीशन वेक्टर है, तो व्हिच टर्म्स आर गोइंग टू एक्ट अलोंग जेड एक्सिस? सर सारे एंगुलर टर्म्स. स्टूडेंट्स ध्यान से सुनना, सारे एंगुलर टर्म्स विल बी ऑन जेड एक्सिस. Students, by analog, that means identically, in resemblance to, alike, almost identical. अगर मैं यहाँ पे लीनियर डिस्प्लेसमेंट यूज करता हूँ फॉर अ पार्टिकल परफॉर्मिंग ट्रांसलेशनल मोशन, कैन आई से फॉर सर्कुलर मोशन आई कैन यूज एंगुलर डिस्प्लेसमेंट? हाँ सर. अगर ये S अगर मीटर में होगा, तो यहाँ पे थीटा रेडियंस में होगा, क्यों नहीं? हाँ सर, ये भी तो है. अभी देखो, जिस डायरेक्शन में एंगुलर डिस्प्लेसमेंट होगा, उसी डायरेक्शन में एंगुलर वेलोसिटी होगा, which is रेडियन पर सेकंड. जिस डायरेक्शन में एंगुलर वेलोसिटी होगा, उसी डायरेक्शन में एंगुलर एक्सेलरेशन भी होगा, रेडियन पर सेकंड स्क्वायर. जिस डायरेक्शन में एंगुलर वेलोसिटी होगा, उसी डायरेक्शन में एंगुलर मोमेंटम भी होगा. जिस डायरेक्शन में एक्सेलरेशन है, उस डायरेक्शन में क्या होगा? टॉर्क भी होगा. ये सारे एंगुलर टर्म्स, थीटा, angular velocity, angular acceleration, angular momentum, torque, all of them are acting along which axis? Plus k cap. Which are the corresponding linear terms? So linear terms is linear displacement. What is displacement upon time? Velocity, acting along one axis. What is velocity upon time? Acceleration. What is mass into velocity? Linear momentum. Which is mass into acceleration? Tangential force. So can I say this is actually for linear and this is for circular? क्या ये clear हुआ? है ना स्टूडेंट्स? ये सारे एनालॉग आ गए. ये देखो, जैसे S आया तो वहाँ पे थीटा है. S by T को भी लिखा, थीटा by T को मैंने ओमेगा लिखूंगा मैं. तो थीटा by T is ओमेगा. What is V by T? A. So omega by T is alpha. Are you getting it? That's how we can put forward for circular and linear. So now can I say, using this concept, can I say by using right-hand screw rule, is this a correct way of representing in vectors? So we'll say yes, sir. Particle is, the answer is in a particle is going in anti-clockwise direction. Yes. Displacement कौन सा axis पे? से displacement axis J है. तो J क्या होना चाहिए? K cross I. K क्रॉस I, K पे थीटा है, हाँ सर आ गया, I पे R है, हाँ सर आ गया. So is this a correct way to write out? Students?
Yes, sir.
Students, when you have done vectors, everybody listen carefully, students. You have done scalars and vectors, you have done dot product and cross product. Students, what have you learned in cross products? Or different case, if I ask you students, when is cross product used in physics? Bolo? Students, throughout physics, mein cross product kahan pe use karoge?
Only in circular and rotational motion.
Very good, Parthy. Very good, Kirti. Students, पूरे फिजिक्स में, पूरे 2.5 साल के फिजिक्स में क्रॉस प्रोडक्ट कहाँ पे यूज होगा? Only if the particle is along an arc with constant radius. That means if the particle is performing circular motion or rotational motion, वहीं पे ही तुम क्रॉस प्रोडक्ट यूज करोगे. क्रॉस प्रोडक्ट और कहीं भी यूज नहीं करोगे. ये ध्यान में रखना students. That is why students, when you all did cross products, what was the only example which your teachers must have picked up? Torque, R cross F. Why? Because that is done in most of the students of class 10th. All ICSE students have done torque is equal to R cross F, moment arm into force. क्या ये clear हुआ students?
So what is written in the second last line of linear?
Linear students, linear displacement, linear velocity, linear acceleration, linear momentum, linear force. Momentum is mass into linear velocity.
Okay,
Force
sir.
is mass into acceleration. क्या ये clear हुआ students सबको? Is this clear?
Yes, sir. Yes.
अभी ध्यान से सुनो students, listen carefully. Listen carefully. Students, अगर suppose मैं इसको differentiate करूँ with respect to time. Let us differentiate this expression with respect to time. तो क्या होगा? मतलब सर ds by dt, d theta by dt. सर radius vector तो constant है, cannot be differentiated, है ना? Position vector. तो क्या होगा? What is ds by dt? So that will be v. What is d theta by dt? Omega cross r. Am I getting the formula of v is equal to omega bar cross r? ये देखो, s is equal to theta cross r. What is v? Omega cross r. अभी ध्यान से सुना students. Forget about this. Students, velocity is acting along which axis? ये v कौन से axis पे act हो रहा है? Is it x, y or z?
Y.
Why?
Y. J cap. J cap. Agreed, everyone.
Yes.
J cap.
Yes, sir.
Agreed. Now, students, is the particle moving clockwise or anti-clockwise? Is the particle moving clockwise or anti-clockwise?
Anti-clockwise.
So how do you write down J cap as? Is J cap K cross I? Is J K cross I?
Yes.
Yes. So now can I say corresponding for linear velocity, you have an angular velocity. Therefore, in K, we have omega, I, we have position. Therefore, omega bar cross alpha. समझ में आया स्टूडेंट्स? ये v bar is equal to omega bar cross r bar हमें मिला कहां से? यहां से आया by using differentiation. लेकिन वो सही क्यों है? क्योंकि अगर ये एंटी क्लॉकवाइज में s is equal to theta cross r है, तो एंटी क्लॉकवाइज मोशन में v is equal to omega cross r ही होगा. स्टूडेंट्स, अगर बाय चांस कोई स्टूडेंट, ध्यान से सुनना, अगर इसको लिखता r क्रॉस थीटा पहले वाले को, तो मेरा ये आंसर किसमें होता? -s. तो करस्पॉन्डिंगली ये क्या होता? r क्रॉस ओमेगा. ये क्या होता? -v. What exactly this shows? Directed opposite. What does this shows? Directed opposite. Is this clear, students?
Yes.
So this speaks about clockwise motion. Students, ये clockwise बता रहा है और ये anti-clockwise बता रहा है. Students, अभी देखो, everybody listening. R कौन से एक्सिस पे? स्टूडेंट्स, R कौन से एक्सिस पे? I है ना? Agreed? Is it clear?
Yes, sir.
Yes, sir.
Yes,
Theta
sir.
is a bit like this. What is I cross K? What is I cross K? What
Minus
is
J.
I cross K will be equal to what? So if I happen to go for I cross K, what exactly consider? Minus J. I get minus J. I cross K minus J. लेकिन ये clockwise motion. क्या ये clear हुआ students? हाँ students? That is why students anti-clockwise movements, my thumb is going to go along positive axis, positive. Clockwise movements, my thumb is going to go along negative axis. And when I made it clear to your students for the sign conventions, what did I tell you? How did physicists came across the sign conventions? Anybody remembers how did physicists say that anti-clockwise is positive and clockwise is negative? क्या सोच के किया था उन्होंने ये? हाँ, anybody remembers? What did I tell you?
Direction of rotation of Earth.
Very good. Nah, absolutely correct. Absolutely correct. She is. This is what it is. Yana said it very correct. Students, मुझे ये बताओ, Earth कौन सी direction में rotate होता है? East to west या west to east? No, students. What is the direction of rotation of the Earth? West to east.
West to
East.
It always moves from west to east. अगर मैं west to east जाता हूँ ना, students, where is my thumb pointing? Upwards. If I'm rotating from west to east, take a simple example. So students, take a globe. सोचो तुम्हारे घर के अंदर स्टडी टेबल के ऊपर एक छोटा सा अर्थ का ग्लोब रखा हुआ है, नॉर्थ साउथ वेस्ट एंड ईस्ट. तो हमेशा अर्थ कैसे रोटेट करता है? वेस्ट टू ईस्ट. स्टूडेंट्स, वेस्ट टू ईस्ट करोगे तो तुम्हारा थंब ऊपर की तरफ जा रहा है, एंटी क्लॉकवाइज. ईस्ट टू वेस्ट जाओगे तो थंब नीचे की तरफ आ रहा है. ये साइन कन्वेंशन. क्या ये क्लियर हुआ स्टूडेंट्स?
yes, sir.
students?
Yes, sir.
Yes, sir.
अगर तुम देखोगे ना स्टूडेंट्स, अगर तुम देखोगे ना स्टूडेंट्स, हमें ये फॉर्मूला कहाँ से आया? डिफरेंशिएटिंग दिस. एग्री? सपोज अगर मैं इसको डिफरेंशिएट करूँ, चलो अभी ना डिफरेंशिएट दिस स्टूडेंट्स. Everybody, ये कौन सा velocity students? Is it tangential velocity? Is this tangential velocity students? हाँ या ना? Agreed?
Yes, sir.
Differentiate both
Yes,
the sides
sir.
within. So can I say dv by dt? d omega by dt cross r? Students?
Yes,
What is
sir.
dv by dt? What is dv by dt? Students, what is dv by dt?
Acceleration.
Which acceleration? Which acceleration? Acceleration tangential? Agreed. Which acceleration students? You'll say sir, acceleration tangential. What is d omega by dt? So change in angular velocity is the answer. Angular acceleration cross r. Students, the position vector is of same magnitude. ये constant है. So it's a tangential acceleration is equal to what? Alpha cross r. Now, is it again correct in vector form? Yes, motion is anti-clockwise. Where is acceleration tangential? Sir, y-axis. J, k cross I, k cross I. यानी स्टूडेंट्स सारे फॉर्मूला सर्कुलर मोशन के आते कहां से हैं? डिफरेंशिएशन से. अभी स्टूडेंट्स ध्यान से सुनना. गो बैक टू कैलकुलस. शायद जिसने भी तुम्हें कैलकुलस सिखाया होगा 110% बोला होगा स्टूडेंट्स. अगर तुम डिस्प्लेसमेंट से वेलोसिटी जाओगे तो डिफरेंशिएट ds by dt. वेलोसिटी से एक्सेलरेशन जाओगे तो डिफरेंशिएट dv by dt. है ना स्टूडेंट्स? ये क्या है? ये लीनियर मोशन के लिए. स्टूडेंट्स, इफ यू हैपन टू सी योर कैलकुलस का बुक, वहां पे सर्कुलर के लिए भी दिया है. अगर तुम्हें एंगुलर डिस्प्लेसमेंट दिया है, टू गेट वेलोसिटी डिफरेंशिएट व्हाट? थीटा. इफ आई नो ओमेगा, टू गेट एक्सेलरेशन एंगुलर, डिफरेंशिएट ओमेगा. यानी व्हेन आई मूव फ्रॉम s to v, v to a differentiation, theta to omega, omega to alpha, differentiation. But when I go from a to b, v to s, integration. Alpha to omega, omega to theta, integration. क्या ये क्लियर हुआ स्टूडेंट्स? Differentiating theta with respect to time, angular velocity. Differentiating angular velocity with respect to time, angular acceleration. Is this clear to all of you students?
Yes, sir.
Now the answer is in students. Everybody, okay? Everybody listen carefully. One more concept, okay? And that's a very important concept. Students, when the body is performing circular motion, students, it's circular motion. I'm not taking it as UCM, okay? Simply circular motion, students. Now suppose if I try to take the same expression, students, V bar is equal to omega bar cross R. मुझे ये बताओ स्टूडेंट्स, क्या डायरेक्शन ऑफ पोजीशन वेक्टर हमेशा चेंज हो रहा है? हाँ सर, ये देखो ना, R जहाँ पे भी होगा वहां पे R आएगा. अभी देखो पोजीशन वेक्टर का डायरेक्शन इस तरफ है. जैसे पार्टिकल यहाँ पे होगा तो सर पोजीशन वेक्टर का डायरेक्शन इस तरफ आएगा. जैसे पार्टिकल यहाँ पे होगा तो पोजीशन वेक्टर का डायरेक्शन इस तरफ आएगा. And it does the direction of position vector goes on changing? Yes. Now students listen carefully. Suppose if I take this expression and if I tell you students differentiate the given expression. And in this differentiation students, we go for product rule. Which rule? Product rule, U into V method. Students, आता है U into V method? तुम बोलोगे हाँ सर, पहले हम differentiation dV करेंगे with respect to time, है ना? If I say U into V method students, can I keep U constant?
Yes.
Why not? Differentiate V plus.
V constant.
Yes, differentiating this.
Differentiate V.
Yes, so I'll consider as R. Cross we consider as what? We take it as, I'll take it as dr by d omega by dt. Cross R. क्या ये clear हुआ students? Differentiating omega, keeping R constant. Which method we have used? Students, UV method we have used. मुझे ये बताओ students, ये omega है. Students, मुझे बताओ what is change in direction of position vector with respect to time will give me change in velocity. Change in velocity. Which velocity? Tangential velocity, students. Plus d omega dt is what? Alpha cross R. This is your acceleration net. And students, for a body performing circular motion, how many acceleration the body is possessing? So the body is possessing two accelerations. Students. One is acceleration tangential, and the other one is acceleration centripetal or acceleration radial. So students, when a body is performing circular motion, yeah, non-uniform circular motion, the body will have always two acceleration centripetal, acceleration tangential. लेकिन अगर UCM होगा, ध्यान से सुनना, यूनिफॉर्म सर्कुलर मोशन होगा तो ओमेगा कांस्टेंट होता है. स्टूडेंट्स, ओमेगा कांस्टेंट होता है. अगर ओमेगा कांस्टेंट हुआ तो स्टूडेंट्स डी ओमेगा बाई डी टी क्या बन जाएगा? जीरो. अगर डी ओमेगा बाई डी टी जीरो हो जाएगा, देयर इज नो चेंज इन एंगुलर, तो कहने से ये पूरा प्रोडक्ट जीरो हो जाएगा. यानी टेंजेंशियल एक्सेलरेशन क्या होगा? जीरो. ओह, यानी सर आप ये बोलना चाहते हो कि यूनिफॉर्म सर्कुलर मोशन में the body will have only one acceleration. Yes, students, and that is radial acceleration or centripetal acceleration. But if a body is performing non-uniform circular motion with the velocity goes on changing, how many acceleration the particle has? Two accelerations. One is centripetal acceleration, another one is tangential acceleration. Is this clear to all of you?
Yes, sir.
Sir, can you
Yes.
tell it again, please?
See, listen carefully. Students, what I was trying to say. Who asked this? Janani, you asked me.
Yes, sir.
Janani, now please pay attention, students. I'm happy that Janani raised this question. Many students must have not got this. Janani, you answer to my question. Students, Janani, you are in a car, and the car is going with 80 kilometers per hour. Okay, you are with your dad, and your dad is driving, and the motion is straight path. Motion is straight line. And Janani, your car is in the initial 10 seconds, the speedometer shows 80. Next 10 seconds, it shows 80. The next 10 seconds, it shows 80. The next 10 seconds, it shows 80. At the end of 50 seconds, listen carefully, Janani. At the end of 50 seconds, your dad asks you, Beta, what is the acceleration of the car? So, what answer hoga?
Sir, 80 because it's been uniformly accelerating, right?
Uniformly accelerated. Huh? I repeat, your car was going with a constant speed, constant velocity of 80 kilometers per hour for first 10 seconds. Next 10 seconds also 80. Next 10 seconds also 80. Next 10 seconds also 80. Next 10 seconds. For 50 seconds it was going 80. Your dad asked you, beta, what is the acceleration of the car? What's the formula for acceleration, Janani? Yes, Parthy, absolutely correct. Sanjana, absolutely correct. Janani, what is the formula for acceleration? Can you tell me the formula for acceleration?
Sir, it's velocity by time, right?
Is it velocity by time or change in velocity upon change in
By
time?
change in velocity by change in time.
So what is the velocity before when you saw the stopwatch? What exactly velocity the speedometer was showing you?
Sir, 80 meters per second.
80 kilometers per hour. After 50 seconds
Kilometer.
also what exactly? After 50 seconds also what it was showing you?
80 kilometers per hour.
So what is V minus U?
So 0.
So is your acceleration 0?
Yes.
Is your car at rest?
Yeah.
Huh?
Yes.
Car is at rest?
No, no, no.
My
Car
dear.
is not at rest. Sorry. Car is not at rest.
The car is in? Car is in?
Uniform motion.
It's going with constant speed.
Constant
It's going
speed.
with constant speed. Uniform velocity, we consider the car is going with uniform velocity. Velocity remains constant. So what is dv by dt? What is dv by dt? 0. What is dv by dt? I
Okay.
ना
Yes, yes, it's 0.
acceleration का आंसर क्या हुआ? Acceleration का आंसर क्या हुआ?
0.
ये कौन सा मोशन था जनानी? ये कौन सा मोशन था?
Tangential motion.
लीनियर. कौन सा मोशन
Linear.
था?
Linear
समझ
motion.
में आया? समझ में आया?
Yes, sir.
Now again same example. Everybody listen carefully. Janani, you have to answer same example. Now you are in the same car. You're in the same car, but your dad is now driving in a circular path. He's driving in a circular path.
Okay.
Janani. Okay. Now my question to you is in the first 10 seconds, its angular speed is 80 radians per second. In the next 10 seconds, again it's 80 radians per second. In the next 10 seconds also it's 80 radians per second. In next 10 seconds also 80. After 50 seconds, if I ask you what exactly the angular acceleration of a car is, what will be your answer?
0.
0, because omega was constant.
Yes, omega.
If I'm going for uniform circular motion, friends, if I'm going for uniform circular motion, what exactly d omega by dt will be? 0. Tangential acceleration will be 0. But for non-uniform circular motion, the particle or the body will have 2 accelerations. क्या ये clear हुआ?
Yes, sir.
Please, all the students who are in this particular group or whatever the lectures what you're listening right now, listen carefully, students. If a particle is performing circular motion, dance sunna. And please, if you want, you can put it down very clearly. If the particle is performing circular motion and if the motion is UCM, then the particle possesses only one linear acceleration, and that linear acceleration is called as radial acceleration or centripetal acceleration from the particle along the radius towards the center of the circular path. Acceleration radial or acceleration centripetal is always directed from the particle. I'm repeating again, from the particle along the radius towards the center of the circular path. Whereas for circular motion, if a body performs circular motion and if it's non-uniform circular motion, students, where the direction of velocity and the magnetic velocity goes on changing at each instant, in that case, the body will possess 2 acceleration. One of them is called tangential acceleration and one of them is called centripetal acceleration. एक tangential होगा, एक centripetal. Always 2 acceleration. क्या ये क्लियर हुआ सबको?
Yes, sir.
Yes, sir.
Now can I erase this, students? Can I erase this entire now? And देखो तुम्हें सारे formulas कहाँ से मिल रहे? Differentiation से तो मिल रहे. Using differential equations of what you can get your answer. Is that clear, students?
Yes, sir.
Yes, sir.
Since actually this part should come in motion in 2 dimensions. Actually, 2-dimensional motion when you go for kinematics 2 now. So kinematics 2 के अंदर ये part होना चाहिए at the end of it. Along with projectile, it should be this. And mostly orange batch will be doing this part along with kinematics 2. जो कुछ भी बोला ये सेम चीजें वापस मैं रिपीट करूंगा वहां पे. So please do take care of these things.
Okay, sir.
If possible, you can maintain notes also. Now, students, if you consider UCM, non-UCM, in uniform circular motion, students, the particle has only one acceleration centripetal. Corresponding force is also force centripetal. This is a particle of mass. So, what is the formula for acceleration centripetal? Acceleration centripetal has, in vector form, if I write on students, acceleration centripetal, correct vector form, it's minus omega square into r. Now, students, when I explain to you acceleration centripetal is what? Sir, it's the acceleration which is directed from the particle. Listen carefully, students. I told you very clearly, from the particle along the radius towards the center of the circular path. तो ये कौन सा है? ये acceleration centripetal है, students. मुझे बताओ, radius vector या position vector का direction हमेशा कैसा होता है? सर, opposite. तो उससे क्या नहीं है? Acceleration centripetal and position vector, students, are they in same direction or opposite direction? They are always in opposite direction. That's why we use a negative sign. Students, writing in vector notation, this is how we put forward centripetal acceleration. So, students, centripetal acceleration has how many formulas? 3 formulas. Listen carefully. Your first formula, what you got it, will be what? Omega square into r, students. This I'm writing in magnitude. ये कैसे लिखा मैंने? In magnitude. अभी मैं डायरेक्शन नहीं दिखा रहा स्टूडेंट्स, मैं डायरेक्शन नहीं दिखा, लेकिन अगर किसी ने पूछा व्हाट इज द करेक्ट वे ऑफ राइटिंग इट, ये करेक्ट. अगर किसी ने पूछा भाई एक्सप्लेन करो, तो तुम्हारा आंसर क्या होना चाहिए? सर, सबसे पहले मोशन यूसीएम होना जरूरी है. यूनिफॉर्म सर्कुलर मोशन में तुम्हें कितना एक्सेलरेशन होगा? सर, एक ही एक्सेलरेशन होगा. रेडियल वी कंसीडर इन दिस केस, सेंट्रिपेटल इनवर्स वी कंसीडर. अब इस पोजीशन वेक्टर डायरेक्शन ऑपोजिट. ये तुम्हारा एक फॉर्मूला हुआ. Do you know V is equal to R omega? हाँ सर, आपने अभी डिराइव किया था डिफरेंशिएशन से. Friends, can I substitute R? Can I substitute R as V by omega? So can I say my next formula will be acceleration centripetal will be equal to V into omega? Agree, students? Can I substitute omega over here as V by R? So this is V square by R square. So can I say my next formula will be acceleration centripetal will be equal to V square by R? So students, how many formulas you have for acceleration centripetal? 3 formulas. Omega square into r, v into omega, v square by r. This centripetal acceleration is always in meter per second square, students. The corresponding force we called as force centripetal, which is radially inward force, students. It's a radially inward force. And this centripetal force, students, is called as real force, which you have learned it in what? Students, you must have learned it in laws of motion. NLM के अंदर सबसे पहले ये क्लासिफाई किया होगा. फोर्स को जब भी तुम क्लासिफाई करते हो ना स्टूडेंट्स, 2 फॉर्म में, तो एक आता है रियल फोर्स और दूसरा होता है सीडो फोर्स. Real force and pseudo force. So what is pseudo force? Pseudo force has no origin, no source. The best example of pseudo force is centrifugal force. The best example of real force is centripetal force. ये तुम्हारा centripetal force है. How many formulas are there for centripetal force? There are 3 formulas. Force का equation क्या होगा? So force is equal to mass into acceleration. How many formulas are there for acceleration? 3. So how many formulas for force? There were 3 formulas again. mv square by r, m into v into omega, and r omega square. क्या ये clear हुआ students? 3 formulas. Is this clear, students?
Yes, sir.
Yes,
So in
sir.
uniform circular motion, students, the magnitude of velocity remains constant. Direction of velocity always goes on changing, so the dot product will be always is equal to 0, motion is accelerated. Non-uniform circular motion, my students, speed does not remain constant. Velocity and position vector, students, the dot product is always equal to 0 and they're mutually perpendicular to each other. Students, over here, omega also remains constant. Students, omega over here remains constant, but over here, omega is d theta by dt, and that is not equal to constant. ये ध्यान में रखना. यहाँ पे angular velocity constant, यहाँ पे angular velocity constant नहीं है. यहाँ पे constant नहीं है और यहाँ पे constant है. ये UCM और ये non UCM है. तभी जाके स्टूडेंट्स यहाँ पे एंगुलर एक्सेलरेशन आएगा, तभी जाके यहाँ पे एंगुलर एक्सेलरेशन आएगा, तभी जाके यहाँ पे टेंजेंशियल एक्सेलरेशन आएगा. स्टूडेंट्स देखो ना, जहाँ पे ओमेगा होगा वहां पे अल्फा आएगा. ओमेगा देखो डी थीटा बाई डी टी, तो अल्फा का फॉर्मूला क्या होगा? डी ओमेगा बाई डी टी, क्योंकि कांस्टेंट नहीं है. जहाँ पे अल्फा आया तो वहां पे टेंजेंशियल एक्सेलरेशन आएगा. हाँ सर, आर इन तो अल्फा भी आएगा. यानी फॉर नॉन यूसीएम स्टूडेंट्स, फॉर नॉन यूसीएम, हाउ मेनी एक्सेलरेशंस द बॉडी इज गोइंग टू हैव? How many accelerations the body is going to have? 2 accelerations, students. Which are they? One is tangential acceleration and one is centripetal acceleration. Centripetal is required for the body to have a circular path. So centripetal acceleration के time पे always V and R are mutually perpendicular. वो body का direction change कर रहा है. यहाँ पे भी direction change करने के लिए जरूरी है. लेकिन साथ में टेंजेंशियल भी आता है. क्यों टेंजेंशियल आया? स्टूडेंट्स, अगर किसी ने पूछा क्यों टेंजेंशियल आया, तो तुम्हारा आंसर क्या होगा? सर टेंजेंशियल इसलिए आया क्योंकि अल्फा है, एंगुलर एक्सेलरेशन आया. किसी ने पूछा भाई क्यों एंगुलर एक्सेलरेशन आया? क्योंकि डी ओमेगा बाई डी आया है. डी ओमेगा बाई डी क्यों आया? क्योंकि ओमेगा कांस्टेंट नहीं है. वो यहाँ पे ओमेगा कांस्टेंट था. अगर ओमेगा कांस्टेंट था तो यहाँ पे अल्फा 0 हो गया और यहाँ पे टेंजेंशियल एक्सेलरेशन भी 0 हो गया. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
So
Now, if I
what's
happen to
written there in force centripetal is equals to radian? It's what I couldn't
It's a real
understand that.
force. Centripetal is a real force. A real
So in
force.
front of that,
It's radially inwards. Okay, Parthy. Acceleration centripetal का direction कहाँ पे है? Acceleration centripetal. The word centripetal is centrally seeking acceleration. उसका
So I
direction कहाँ
got
से?
that. I just wanted to know what is that written. I was confused.
Fine. I know that. It's directed from the particle towards the center.
Center, yes.
ये भी क्या है? Radially inward force है. उसी डायरेक्शन में. यानी देखो ये ध्यान रखना, जिस डायरेक्शन में एक्सेलरेशन होगा उसी डायरेक्शन में फोर्स भी होगा. तो रेडियली इनवर्ड फोर्स.
Okay, sir.
Alfie, are you getting it? Because you're asking me over here. I've reached over here.
No,
Alfie?
sir. I was just writing it down.
Okay, fine. So students, for non-uniform circular motion, how many accelerations there are? 2 accelerations. And how are these 2 accelerations mutually perpendicular, students? इनका resultant can you find out? हाँ sir, इसको shift कर दो parallel. Tail, head. Using triangle of vector addition, what is my resultant? आ गया. Diagram से ये आया. Students, diagram से ये आया. And do you recollect? When we used V bar is equal to omega bar cross R bar, students, UV method हम लोग ने लिया था. Sorry. V bar is equal to omega bar cross R bar, students. We use product rule. है ना? Keeping omega constant, differentiating dr by dt. Agreed? Then differentiating d omega dt, R constant. So did I get the same relation over there? Yes. तो ये तुम्हारा क्या net acceleration? Students, अगर किसी ने पूछा what is the magnitude? What is the magnitude of net acceleration? तो क्या करोगे? So simple vectors है ना? Using parallelogram of law of vector addition, what is the angle from between these two? I can consider both the vectors are mutually perpendicular to each other. Then I say it's under root AR square plus AT square. हो गया तुम्हारा आंसर. If acceleration net is this, what is force net? Sir, force radial plus force tangential. What is force radial is called as? This is called as force centripetal. Friends, radial force is called as force centripetal. ये इसके 3 formulas हैं. Friends, ये 3 formulas यहाँ पे है centripetal force के. Tangential force के कैसे formula लिखोगे? So tangential force is mass into acceleration tangential. What is the formula for acceleration tangential? R alpha. Okay, then m into r into alpha. How do you find out the magnitude of this? So this is also by using parallelogram law of vector addition. Can I say it's fr square plus fp square? Students, ये पूरे कंसेप्ट में मैंने क्या किया, सिर्फ वेक्टर्स ही यूज किया है. यहाँ पे बॉडी, अगेन आई एम टेलिंग स्टूडेंट्स, ये नॉन यूसीएम है. नॉन यूसीएम के अंदर 2 एक्सेलरेशन होंगे, एक टैंजेंशियल होगा और एक सेंट्रिपेटल होगा. अगर जिस ऑब्जेक्ट को 2 एक्सेलरेशन होंगे तो 2 फोर्स भी तो होंगे ना, मास इनटू एक्सेलरेशन. तो एक टैंजेंशियल और एक सेंट्रिपेटल, तो एक नेट फोर्स भी आएगा, नेट एक्सेलरेशन भी आएगा. अगर किसी ने पूछा व्हाट इज द डायरेक्शन ऑफ रिजल्टेंट, स्टूडेंट्स व्हाट इज द डायरेक्शन ऑफ रिजल्टेंट, तो वेक्टर्स में तुमने किया है. ठीक है, लेट अस टेक इट एज अल्फा. Do you recollect we have learned about parallelogram law of vector addition में alpha is equal to tan inverse of b sin theta upon a plus b cos theta. वैसे यहाँ पे देखो, what is alpha? What is alpha? Direction of resultant. What exactly be? Tan inverse of what? Acceleration tangential upon acceleration centripetal. This is a formula for alpha. क्या ये क्लियर है अभी? Alpha is tan inverse of tangential upon centripetal. Yeah, instead of alpha, students don't put alpha because alpha is angular acceleration. तुम लिखो phi. Take another angle. Take angle phi. Tan inverse of tangential upon centripetal. क्या ये क्लियर हुआ स्टूडेंट सबको?
Yes, sir.
Students, hope it's getting clear to all of your students. Clear हो रहा है students? Everyone.
sir.
Akshita, Ayush, Aisha, Akmal,
Yes, sir.
Anirudh. What about you, Anirudh?
Yes, sir.
Okay, Kirti, what about you?
Yes, sir, it's clear.
Gauri, Meera, Om. Gauri, Meera, Om. Gauri, what about you? Meera, what about you? See, no reply from them. This is what it is. Okay, fine, students. Can I erase this students now?
Yes, sir.
Yes, sir.
What happened?
Sir, can you just explain the last part a little bit?
Which last part?
Sir, actually, can you just, yeah, from the net, yeah, that part.
That is actually angle. That's the direction of resultant. Suppose if I give you a vector vertical and vector horizontal, how do you find out the resultant का direction? If I give you 2 vectors which are mutually perpendicular, generally, मुझे बोलो इनका resultant कहाँ पे होगा? 2 vectors are intersecting at the tail. Where is the resultant will be of these 2 vectors?
At the intersection, right?
No, what is the resultant of these 2 vectors? I'm showing you in front of you. What is the resultant of these 2 vectors? कहाँ पे होगा?
Sir, as in, I got confused.
My dear Janan is not confused. This is not revising at all. 2 vectors intersecting at their tails, they form adjacent side of a parallelogram. The resultant is always drawn from the point of intersection along the diagonal of the
Okay,
parallelogram. So
okay.
form parallelogram law of vector addition.
Sorry, sir, it went past my head.
ऐसे मत करो. तो वहां पे अल्फा मैंने वहां पे ये फी निकाला. What is tan phi? Opposite upon adjacent. तो phi is tan inverse. AT upon acceleration tangential upon acceleration centripetal.
Okay, sir.
Okay, that's the direction of the result.
Okay.
Students, See, bottom line, what you have to keep in mind in these two, है ना, एक simple concept हमेशा जब भी तुम circular motion को हाथ में लेना students, हमेशा दिमाग में ये रखना, UCM में students, UCM में only one linear acceleration it is, only acceleration centripetal, so called as radial acceleration. But whenever they ask you for non-UCM, how many acceleration, तुरंत तुम्हारे दिमाग में दो आना चाहिए, एक होगा tangential और एक होगा centripetal. अगर तुम्हें किसी ने पूछा भाई centripetal क्यों, तो तुम्हें ये बोलना है सेंट्रीपिटल की वजह से ही तो बॉडी सर्कुलर पाथ घूमेगा ना, बिकॉज V and R are all the time mutually perpendicular. That is why centripetal comes in both. That is a common term held in both. That's why motion is accelerated. Now, second part, in UCM, omega remains constant. In non-UCM, omega does not remain constant. तभी जाके students in UCM, alpha is 0. There is no tangential acceleration. Whereas in non-UCM, omega is not constant. जहाँ पे omega constant नहीं होगा, तो वहाँ पे alpha भी होगा, tangential acceleration भी होगा. अगर tangential acceleration होगा, तो दो acceleration की वजह से एक net acceleration develop होगा. अगर net acceleration है, तो net force भी होगा. Force is mass into acceleration. खत्म होगी बात. This is how students should keep in mind. Agree?
Yes, sir.
Okay. Now comes your last part of your vertical circular motion, students. Okay, so keep in mind. Now you go for vertical circular motion. This vertical circular motion is a non-uniform. A non-uniform circular motion. Students, I'll consider this. Now, the best example of vertical circular motion, students, you can consider is a giant wheel. Take in this example, a giant wheel. Since if I happen to go for a particle performing vertical circular motion, students, along the circumference, if I consider, this is the center of the circular path. Please pay attention, students, okay? First of all, let us say that where is a tension maximum and where is a tension minimum. Students, कभी भी circular path में तो देखो ना students. So for a body moving in anti-clockwise direction, students, tension is always maximum at the lowest point. L stands for lowest point, students. D stands for diametrically opposite points. And H stands for highest point. Students, do keep in mind, tension at lowest point is always maximum, and that is always 6 mg. Students, tension at the lowest point is always 6 mg. Tension, students, at highest point is always 0. At the highest point, tension is always 0, students. Tension at diametrically opposite points is always 3 mg. Do keep this in mind. These are the three important values which a student should keep in mind. And for vertical circular motion, students, हमेशा tension कहाँ पे maximum होगा? Lowest point पे होगा. 0 कहाँ पे होगा? Topmost position पे. अभी कोई student पूछेगा सर क्यों आप बोल रहे हो कि tension 0 ना चाहिए? Students, अगर यहाँ पे 0 होगा तो यहाँ पे maximum होगा. And we can easily get it, students, by simply trying to go for forces, free body diagrams. Now, suppose if I happen to consider, students, listen carefully. Try to take a particle, students. Okay, a particle of mass m, students. For example, a stone. At any instantaneous position, let us say the object is over here and it is held by a string. So, चलो ये stone को मैंने held by a string किया है. So can I say ये हुआ radius? This is the radius of the circular path. Let us say that string has undergone a displacement at an angle theta with a vertical. Which ये बताओ students, जब ये stone यहाँ पे है, students, for vertical circular motion, students, how many forces are acting? how many forces are acting students? So तुम क्या बोलोगे? If I take a thread, tie a stone to it, and I'm making the stone to revolve in a vertical plane, students, in an anti-clockwise direction, my question to you is, at any instantaneous position P, this is my question to you, what are the forces acting onto this? So what will be your answer? What will you say? Sir, एक तो stone का, it's a free body diagram, students. Yes, absolutely correct, Pa. Sorry, Pathvi. Yes. Kirti, Pathvi has given the answer. एक तो mg नीचे की तरफ act होगा. Weight is always acting whatever. Which is the force of tension? How is the tension directed from the stone towards the point of suspension? क्या ये दो forces clear हुआ, students? They are contact forces. हाँ, students, क्या ये clear हुआ, students?
Yes.
Yes.
अभी मुझे
Yes,
बताओ,
sir.
अभी मुझे बताओ, सपोज अगर मैंने ज्यादा फोर्स नहीं लगा स्टूडेंट्स, अगर सफिशिएंट, सपोज अगर ये स्टोन यहाँ पे था, उसको मोशन के लिए ऐसे जाएगा, ये लीनियर वेलोसिटी होगा स्टूडेंट्स. अगर सपोज मैंने स्टोन को सफिशिएंट वेलोसिटी नहीं दिया, स्टूडेंट सफिशिएंट वेलोसिटी नहीं दिया, तो कैन आई से द सेम स्टोन कैन कम बैक टू इट्स मेन पोजीशन? यानी देयर इज सम फोर्स व्हिच इज ट्राइंग टू ड्रैग the force which is trying to drag the particle back to its main position. So what should I go for? So let us resolve mg into two components. ये देखो, ये थीटा, तो कहने से करस्पॉन्डिंग ये थीटा होगा. तो कैन आई रिजॉल्व mg? हाँ सर, ये होगा mg cos थीटा. ये क्या हो जाएगा? mg sin थीटा. फ्रेंड्स, mg sin थीटा कौन सा फोर्स होगा? रिस्टोरिंग फोर्स. यानी फ्रेंड्स, वर्टिकल सर्कुलर मोशन के अंदर अगर तुमने ऑब्जेक्ट को सफिशिएंट वेलोसिटी नहीं दी, लोएस्ट पॉइंट पे सफिशिएंट वेलोसिटी अगर तुमने ऑब्जेक्ट को नहीं दी, तो कौन सा फोर्स उस बॉडी को अपने जगह पे लेके आएगा? mg sin थीटा. अरे सर, ये तो एग्जैक्टली इंक्लाइन प्लेन के हिसाब से गया. हम लोग ने एनएलएम में वो पढ़ा था, लॉज ऑफ मोशन में पढ़ा है. ये एंगल थीटा है, ये मेरा पॉइंट मास हो गया, ये मेरा mg नीचे की तरफ जा रहा है, ये नॉर्मल रिएक्शन फोर्स ऊपर की तरफ जा रहा है. अगर सपोज मैंने सफिशिएंट फोर्स इस तरफ नहीं दिया, मेरा अप्लाइड फोर्स इज लेस, या मैंने फोर्स को काट दिया, तो बॉडी स्लाइड होकर नीचे की तरफ जाएगी, लेकिन किसके हिसाब से जा रही है? mg sin थीटा के हिसाब से जाएगी. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Now when you look into it, students, ये देखो, now can I say how many forces are acting on the stone? So there are two forces, T and mg cos theta. Agreed? Is the body performing circular motion? Yes. So for circular motion, students, for circular motion, you need which force? Force centripetal. यानी तुम्हारा inward force, ध्यान से सुना स्टूडेंट्स, तुम्हारा inward force should be greater than mg cos theta, students. और इनका जो डिफरेंस होगा ना, that is actually your force of centripetal. So the difference between these two forces is actually the net force required for the body to perform circular motion. So now see, what is the equation I'm getting it? Tension at point P minus mg cos theta is equal to mg square by r. So can I get the formula for tension at any instantaneous position P? What's my formula? mg cos theta plus mg square by r. क्या ये क्लियर हुआ स्टूडेंट्स? Is this formula clear to all of you all? Students, tension at
Yes, sir.
point P is equal to mg cos theta plus mv square by r. अभी जैसे तुम्हें tension मिला, can you get the velocities? Why not? You can get the velocity. So मुझे बताओ, what is the tension? Where is the tension maximum at? Which point? Which point? Lowest point. So suppose अगर मैं lowest point के लिए जा रहा हूँ, the answer is gonna students, lowest point. Students, at lowest point put tension is how much? Suppose अगर ये point P lowest point पे है, तो क्या रखोगे? tension को क्या रखोगे students यहाँ पे? What will put tension as? 6 mg. Agreed? Students, lowest point.
Yes, sir. 6
Yes, sir.
Is equal to mg. What exactly theta will be when point P reaches the lowest point? What exactly theta will be? What is theta going to be?
0,
Cos of 0 क्या होगा? What is cos of 0?
1,
1 plus, can I say mv square by r? Can I find the velocity at the lowest point? What is 6 mg minus mg? What is 6 mg minus mg?
5 mg,
Is equal to mv square by r. Mm will get cancelled. So what's the velocity at the lowest point? What's the velocity of the lowest point for vertical circular?
5g,
अंडर रूट 5g/r. क्या ये मैं वेलोसिटी बोल चुका था पहले, है ना? समझ में आया ना स्टूडेंट्स? व्हाट्स द वेलोसिटी ऑफ द लोवेस्ट पॉइंट? अंडर रूट 5g/r. यानी स्टूडेंट्स लेक्चर के बाद में एक बकेट लेना, उसके अंदर पूरा पानी रिम से भर के रखना, पूरा ब्रिम तक भर के रखना, और फिर यू मूव योर हैंड. स्टूडेंट्स जब तक बकेट को लोवेस्ट पोजीशन पे, जब तक बकेट को लोवेस्ट पोजीशन पे स्टूडेंट्स, जब तक बकेट को लोवेस्ट पोजीशन पे, if in case if I don't get the sufficient velocities under root 5g/r, sufficient velocities under root 5g/r, students, the bucket will not complete entire circle. The bucket will go up or will reach over and the water will fall. So what is the velocity at the lowest point? Under root 5g/r. क्या ये clear हुआ students? Is this clear students to all of you all?
sir.
Yes.
Yes.
So can you tell how the tension at the lowest point is 6 mg?
My dear, I'll come to that. First, let me complete with this. आएगा सबको ही बताऊंगा. Don't worry. ये clear हुआ तुम लोगों को सबसे पहले?
Yes.
Now suppose अगर मैंने लिया diametrically opposite point, students. When I go for diametrically opposite, what is theta becoming? Students? What is theta
90.
becoming? Okay, diametrically opposite points. What's theta? 90. What is cos of 90? 0. Can you tell me what is the tension at point D? Sir, mg cos theta, cos of 90 is 0. Agreed? Which is equal to mv square by r. What's the velocity? What is the tension? What is the tension at the diameter? What's the tension at the diameter? How much it is? So what is the formula for velocity? Can I say this is the formula for velocity along the diameter? क्या ये clear हुआ students? यानी जब भी lowest
sir.
position पे होगा उसका velocity under root 5g होगा. Students जैसे particle ऊपर, students think as if you are in a giant wheel. Students शायद तुम लोग शायद amusement park में गए होंगे, एसएलवर्ड जाते हो या कहीं और जाते हो, तो वहां पे एक बड़ा सा giant wheel होता है. तो जैसे तुम बैठोगे तो यहाँ पे तुम ऊपर की तरफ जाते हो तो तुम्हारा velocity भी कम होगा, फिर जैसे नीचे आते हो तो स्पीड बढ़ेगा. तो नीचे अंडर रूट 5g/r डायमेट्रिक लगे तो अंडर रूट 3g/r. टॉप मोस्ट पोजीशन पे पहुंचेगा तो क्या होगा? सर टॉप मोस्ट पोजीशन पे तो टेंशन 0 है, तो इसको 0 डाल दो. एट हाईएस्ट पॉइंट इसको 0 डाल दिया मैंने. व्हाट इज थीटा? फ्रेंड्स व्हाट इज थीटा एट हाईएस्ट पॉइंट? थीटा एट हाईएस्ट पॉइंट इज हाउ मच? 180 डिग्री, 5 रेडियंस, है ना स्टूडेंट्स? At highest point from lowest point to higher points, what is theta? 180. So what is cos of 180? What is cos of 180? -1. Agreed? Cos of 180 क्या होगा? -1.
-1.
Plus mv square by r. Can I rearrange it? Can I get it? B is equal to under root rg. क्या ये clear हुआ? So what's the velocity at the topmost position? Under root rg. What is the velocity at the diametrically opposite points? This is under root rg. यहाँ पे क्या है velocity? Sir, यहाँ पे velocity is under root 3g/r. What is the velocity at the lowest point? Under root 5g/r. क्या ये clear हुआ students?
Yes, sir.
Everybody, students, I gave you the formula for tension of any instantaneous position P. Formula is mg cos theta plus mv square by r. Now I gave you tension at highest point, lowest point, and diametrically. From there I got velocity. Now, when I was explaining with that time itself only, maybe 1 or 2 students keep to as put up exactly 6 mg कहाँ से आया? कीर्ति, वेलोसिटी के लिए जब मुझे 6 mg मिल सकता है, यानी to get velocity I'm taking the help of 6 mg. To get 6 mg, can I take the help of velocity?
Yes, sir.
Yes. But answer सुना. जब भी स्टूडेंट्स एवरीबॉडी लिसन केयरफुली, सबसे पहले क्या करते मालूम है? जब भी इसका डेरिवेशन समझ रहे हैं ना, हमेशा हाईएस्ट पॉइंट के लिए जाओ, हमेशा हाईएस्ट पॉइंट के लिए जाओ. Before going for the students, can I erase this because I need a board? This
Yes,
is over.
Sir, 1 minute.
And students, this is the last concept of your chapter. Vertical circular motion, students, is a motion which is non-uniform in nature, we consider, where velocity, magnitude of velocity goes on changing at each instant. Direction is always perpendicular to the position vector. Agreed? The formula for tension is any instantaneous position is mg cos theta plus mv square by r. Tension at the lowest point is always 6 mg maximum. Highest point is always 0. Diametrically opposite points is always 3 mg. Velocity, minimum velocity required. The answer is minimum velocity required at the lowest point is 105 gr. Students, if you happen to see some amusement parks or somewhere into shows, okay, जहाँ पे एक sphere दिया है और यहाँ पे एक bike rider है. Students, एक bike rider है. वो बेचारा bike rider is trying to put his bike in this manner और वो horizontally move कर रहा है. Students, वो पूरा cycle rotate कर रहा है. अभी टायर जैसा है, ये तुम्हारा handle है. Students, लेकिन वो गिरता नहीं है, पूरा एक वर्टिकल सर्कल करके वापस आता है. लेकिन ये कभी पॉसिबल होगा मालूम है? कभी ये बंदा पूरा सर्कल, जब भी उसको एक सफिशिएंट वेलोसिटी नीचे होनी जरूरी है, और वो हमेशा कितनी होनी चाहिए? √5 g. Minimum velocity required should be √5 g for one, यानी always your velocity is greater than √5 g. अगर बाय चांस कम हुआ तो शायद वो ऊपर जाके नीचे आ जाएगा, या ऊपर जाने के बाद में it will fall vertically downwards. Is this clear, students?
Yes, sir.
ना ध्यान से सुनो students, okay? अभी तुम्हें ये जो कंसेप्ट है ना students, इसके लिए क्या करो मालूम है? Always try to first, whenever you go for derivation, this would always try to go for topmost position. तुम्हारा आंसर क्लियर हो जाएगा. Everybody is in students. आंसर देखें students. ये सोचो कि ये गाड़ी है जो कॉन्वेक्स ब्रिज पे है, और ये जो गाड़ी है वो कॉन्केव ब्रिज पे है. मुझे बताओ ये एग्जांपल किसके लिए हुआ? वर्टिकल सर्कुलर मोशन के लिए हुआ कि नहीं हुआ? कार एट द टॉपमोस्ट पोजीशन. आया ना स्टूडेंट्स? हाँ स्टूडेंट्स,
Yes, sir.
मुझे बताओ जब ये टॉपमोस्ट पोजीशन पे होगा तो हाउ मेनी फोर्सेस आर एक्टिंग? तुम्हें लगा सर mg नीचे की तरफ एक्ट हो रहा है. एग्रीड? नॉर्मल रिएक्शन फोर्स किस तरफ जा रहा है? ऊपर की तरफ जा रहा है ना? एग्रीड?
Yes, sir.
Now, is a car performing circular motion? हाँ या ना? हाँ students, is a car performing circular motion? It's on a convex bridge. Is it performing circular motion? अगर वो सर्कुलर मोशन परफॉर्म कर रहा है तो उसके लिए मुझे फोर्स सेंट्रीपिटल चाहिए कि नहीं चाहिए? हाँ सर चाहिए. तो उसके लिए कौन सा फोर्स ग्रेटर होना चाहिए? सर माय mg शुड बी ग्रेटर देन द नॉर्मल रिएक्शन फोर्स. यानी स्टूडेंट तुम्हारे यहाँ पे इक्वेशन होगा mg माइनस n इज इक्वल टू mv स्क्वायर बाय r. लेकिन स्टूडेंट्स, when a car, ध्यान से सुनना, when a car reaches at the topmost position for a fraction of second, the passengers, the car, and the tires of the car at times just lose contact. For a fraction of a second, they lose contact. That means at the highest point, the normal reaction force at that instant we can consider as 0. Students, अगर मैं normal reaction force को 0 ले लूँ, तो can I say my answer for V is equal to what? √gr आ गया. क्या ये clear हुआ students? Ayana, is it clear?
Yes, sir.
Agreed? So is it clear? Are you getting it?
Yeah.
Now once when I get the velocity as 100 RGR, students, by using law of conservation of energy, can I get velocity at the lowest point as 105 GR? Students, यहाँ पे 100 GR मिला है. Can I get by law of conservation of energy, total mechanical energy over here is total mechanical, so can I get velocity as 105 GR at the lowest point? Why not?
Yes, sir.
जैसे तुम्हें velocity 105 G रहा है, what is cos of 0? 1 at the lowest point. So can I say mg cos of 0 is 1 plus v 5 gr by r gets cancelled, 6 mg. I get तुम्हारा आंसर. यानी स्टूडेंट्स 6 mg लाने के लिए हमेशा ये ध्यान में रखना, ये सबसे बहुत इंपॉर्टेंट है. जैसे तुम टॉपमोस्ट पोजीशन में तो वहां पे ये वेलोसिटी निकालना सबसे पहले है. नॉर्मल रिएक्शंस को फॉर फ्रैक्शन ऑफ सेकंड यू कंसीडर द बॉडी इज जस्ट पंपिंग स्लाइटली अवे फ्रॉम द ग्राउंड. उस इंस्टेंट पे n को 0 ले लो तो तुम्हें भी मिल जाएगा. जैसे तुम्हें यहाँ पे भी मिला बाय लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, तुम्हें 105 GR आ जाएगा. जैसे तुम्हें 105 GR आ गया, डाल दो यहाँ पे. लोएस्ट पॉइंट पे थीटा क्या बन जाएगा? 0. आ गया मुझे 6 mg. क्या ये क्लियर हुआ स्टूडेंट्स? Is this clear?
Yes, sir.
Yes, sir.
Yes.
The students, for circular motion, this is the part which you just keep in mind. Okay, so the rest of it, it's only the formulas. Just go through the vertical circular motion. The total mechanical energy all the time remains constant, students, and that's 5/2 mgr. Okay, so that is not the first book, but still one can easily get the answer, students. Okay.
Yes.
So kindly revise it and learn the formulas. Okay. Next lecture will be continuing. If any other topic, we'll continue further it from there.
Okay, sir.
Sure. We'll wind up the sessions. Okay.
Thank you, sir.
Thank you, sir.
Awesome.
Bye, sir.
Bye bye.